Electric cars, or EVs, work by using electric motors powered by rechargeable batteries, rather than internal combustion engines that rely on gasoline or diesel. Here's a breakdown of the key components and how they function together in an electric vehicle. 1. Electric motor. The electric motor is the core of an electric vehicle's propulsion system. It converts electrical energy from the battery into mechanical energy or motion that drives the wheels. How it works is when you press the accelerator, power flows from the battery to the motor. The motor rotates a shaft which turns the car's wheels, propelling the vehicle forward. Types of motors include AC motors, which are more common in EVs, using alternating current for efficient speed and torque control. Then there are DC motors. Direct current motors are simpler and sometimes used in smaller or older EVs. 2. Battery pack. The battery is the EV's energy source, storing electricity to power the motor and other electronic systems in the car. How it works is that most modern electric cars use lithium-ion batteries because of their high energy density and longer life. These batteries store electrical energy generated from charging stations or home chargers. The range, or the capacity of the battery, measured in kilowatt hours, determines the vehicle's driving range. Larger batteries provide longer ranges but may take longer to charge. 3. Power inverter. The power inverter converts the DC power from the battery into AC power for the electric motor, for cars using AC motors. How it works is since batteries store energy in DC but most EV motors run on AC, the inverter plays a critical role in converting energy. It also works in reverse during regenerative braking, converting the AC energy generated by the motor back into DC to recharge the battery. The charging system allows the vehicle to recharge its battery from external power sources like home chargers or public charging stations. There are different types of charging. First we have level 1, which uses home outlets. It's a slow charging method that utilizes a standard household outlet. Next is level 2, which involves dedicated chargers. This method is faster and uses a special charging unit, often installed at home or found in public spaces. Lastly, there's DC fast charging, found at charging stations. This rapidly charges the battery by bypassing the vehicle's internal AC converter. The regenerative braking system converts kinetic energy from braking back into electrical energy, which is used to recharge the battery. So, how does it work? When the driver applies the brakes or decelerates, the electric motor switches to generator mode. It converts the car's motion back into electrical energy and feeds it into the battery. This process helps extend the driving range. The transmission transfers power from the motor to the wheels. Unlike traditional cars that require multi-gear transmissions, most electric cars have a single-speed transmission. This is because electric motors produce consistent torque at all speeds. This simplicity increases efficiency and reduces maintenance. The controller, also known as power electronics, plays a crucial role in electric vehicles. It manages the flow of electricity from the battery to the motor based on inputs from the driver, like pressing the accelerator or braking. Essentially, it regulates the speed and torque of the electric motor by controlling the electrical energy going into it. Moreover, the controller is responsible for managing regenerative braking and the charging process. The Battery Management System, or BMS, is vital for the safety and efficiency of the battery pack. Its primary function is to protect and monitor the battery pack to ensure it operates safely and efficiently. The BMS keeps an eye on the voltage, temperature, and current across the battery cells, ensuring the battery doesn't overheat or overcharge. By doing this, it optimizes the battery's performance and longevity. The thermal management system is essential for regulating the temperature of the battery, motor, and other electronic components. This system helps maintain efficiency and prevents overheating. Electric cars typically use a liquid or air-based cooling system to keep the battery at an optimal temperature. Proper temperature management is crucial because batteries can degrade if they get too hot or too cold. The charging port is the access point where the vehicle connects to external power sources for recharging. It's designed to be compatible with different types of chargers, depending on the car's design. The charging port directs electricity from the charger into the battery for storage, ensuring your electric vehicle is ready to go when you need it.